At Cape Kennedy Air Force Station, the Titan 3C placed the last of a series of satellites into equatorial orbit. These satellites, now 25 in all, form a ring around the Earth to carry out space experiments and to secure the worldwide military communication systems of our Department of Defense. The versatile Air Force Titan 3C is now programmed for other, more complex missions in space exploration. In every space and defense mission on the Eastern Test Range, the planning, coordination, and technical support provided the range users is truly impressive in terms of men, money, time, and physical resources. This intensive effort, devoted to the successful accomplishment of a missile test or space program, is provided through the acquisition of data and the detailed, exhaustive study of every factor related to a launch, long after the termination of the mission. Typical of this continuing pursuit of technical achievement is the conclusion of the Minuteman II program and the introduction of the new advanced Minuteman III missile system. Gradually, the now operational and reliable Minuteman II intercontinental missile will be replaced by the more versatile Minuteman III, with its greater range and improved flight performance. In 1968, as in years past, the National Range's resources afforded heavy support to range users, whose programs depend on the Air Force's facilities, instrumentation, and experience for the success of their scientific and manned flights, as well as defense projects. Among such range users is the United States Navy. During 1968, the Navy continued test-firing Polaris missiles from submarines operating out of Cape Kennedy Air Force Station's port facilities. Many of these tests at the Eastern Test Range were return engagements for submarines and crews. However, there was one newly commissioned nuclear submarine which had her first missile test mission. She was the British Navy's HMS Resolution. As a member of the North Atlantic Treaty Organization, the United Kingdom will soon have 4 such Polaris submarines on patrol, with those of our own Navy, as an integral part of a combined force for security against military aggression. The Resolution's test firings on the Eastern Test Range were highly successful, marking another historic accomplishment on the Air Force's national ranges. Before the end of the year, a new land-based launch complex was readied for the first Poseidon ICBM. Like the Air Force's Minuteman III, the Poseidon is an advancement in concept and performance and will replace the operational Polaris missile. The initial series of Poseidon tests are being launched from Cape Kennedy. The Air Force support of the Navy Poseidon program is not confined to range instrumentation and technical facilities, but includes many other base support activities. Ultimately, submarines, presently being modified to handle a larger missile, will put out to sea to fire the Poseidon down the eastern test range. The Poseidon was launched, as scheduled, at dawn on 16 August 1968. The full resources of the Air Force's Eastern Test Range helped make this event a milestone in our nation's progressive advance in sciences and technology. The Eastern Test Range has a prime responsibility to provide all NASA manned space programs the necessary support required for the manned flight. From the early Mercury flight through the successful Gemini program, the Air Force Eastern Test Range provided NASA with data gathering, communications facilities, and other Air Force technical resources. A fleet of 8 airborne range instrumentation aircraft, known as Araya, operated and maintained by the Air Force, are based at the Eastern Test Range. Carrying the most sophisticated electronic equipment, including a 7-foot telemetry dish, these converted KC-135s may be stationed at points around the world. Wherever reception of telemetry data, or even voice relay from America's space experiments is critical, Araya can be there. The island range stations and the Air Force ships and airborne range instrumentation with skilled and experienced personnel make a significant contribution to the nation's manned space efforts. Now, the national ranges have moved to the support of the Apollo program. Through these resources, manned lunar landings and surface exploration will be possible in this decade. The first of the manned Apollo launches took place on 11 October 1968. The action climax of an eventful year occurred during its waning days. The Saturn V was the sleigh which carried a Christmas present to the entire world. The astronauts were carefully suited up for the Apollo 8 mission. The crew included Colonel Frank Borman of the Air Force, Flight Commander, and Navy Captain James Lovell. The third member of the team was Major William Anders, Air Force. Each man carried his own air supply as they left the suit-up area and boarded a transfer van. The first leg of the moon journey had begun. In the Eastern Test Range Control Center, highly trained Air Force range safety officers were alert to the slightest unusual event. Theirs was the complex responsibility for range safety. If excessive deviation should occur during powered flight, the range safety officer would make the decision to terminate the flight to protect life and property. But the countdown proved perfect. The long-established target time of 7:51 a.m., December 21st, 1968, was met precisely. Stationed at an altitude of approximately 40,000 feet, the range's airborne lightweight optical tracking system, called ALOC, acquired the vehicle and recorded shutdown of the 5 engines of the first stage. First, the center engine, then the outer ones cut off. The big camera in the streamlined pod continued to track the Saturn as the first stage separated, and the second stage began to deliver its 1 million pounds of thrust. The Air Force National Range Instrumentation Resources, positioned round the globe, recorded and relayed the electronic signals which told of a perfect flight. Shortly, the jubilant astronauts were committed to translunar trajectories. In the new freedom of weightlessness, they worked with enthusiasm. It was Christmas Eve when Apollo 8 approached the moon and decelerated to swing into orbit some 70 miles above its surface. Cameras aimed through the viewing port recorded what man was viewing close up for the first time with his unaided eyes. 3 men to the moon and back. A package of achievement to which the Air Force National Ranges had made a major contribution. This nation's Christmas was made brighter with the realization that landing on the moon is now but a short step away. Toward the end of the year, after completing the successful series of flights which placed communications and experimental satellites into orbit, the Air Force began using the powerful Titan 3C for newer and more advanced scientific missions. For this and other new missions on the Eastern Test Range, Air Force management and planning are vital. The resources and facilities of the entire range must meet commitments. To assure that no program is held back by costly delays, range instrumentation has to be ready when called upon. Budget allowances must be made to provide maximum range flexibility for future as well as present programs. Agreements with foreign governments must be continually updated for long-term use of territories needed for land-based range instrumentation stations. Food and supplies must be purchased and transported, often over great distances, to meet range needs. Training programs must be conducted to instruct technical personnel in keeping pace with the ever-changing state-of-the-art instrumentation techniques. Launch support operations are vital to the research and development of our nation's missile test program. To this end, many diverse services and support instrumentation contribute to the successful accomplishment of every complex mission on the Eastern Test Range. It is, in the final analysis, the Eastern and Western Test Ranges, combined as the national ranges under the Air Force Systems Command, which make possible the global support that will help determine our future in space and national defense. This complex network of instrumentation is necessary to support our continued advances in space and our national security in peace.